Hi everyone, and welcome to another lecture. This one is just another lecture on center pivot calculations. So let's read the question. The question says determine the revolution time and gross application at a 75% speed setting for the following case. So the pivot point length is 305.5 meters. So if this is the field, then from the center to the field to the edge of the field is that pivot point length. Then distance to furthest wheel is 280 meters. So you've got your center pivot like this. This is your overhang, then that is the wheel, the furthest wheel, which is 280 meters. Pivot flow rate, which is Q. So that is the rate at which water goes out of the center pivot for a sprinkler. And then motor speed, according to the manufacturer's brochure, is 1.65 meters per minute. So that's an indication of how quickly this thing is moving in circles. And then the wheel slip for the wheels is 3%. So what we want to calculate is the rotation time. So that's T, the gross application, GA, and then we also want to calculate the rotation time at 75% speed and also the gross application at 75% speed. So firstly, let's write down the formulas. So in order to calculate this rotation time, we need this formula of 0.1047 times R divided by V. So this is the time for rotation. So you'll take that 0.1047 multiplied by the speed at which, the radius from the center pivot to the furthest wheel, which is 280 meters, if I remember correctly. And then you'll take that and divide it by this motor speed according to the manufacturer's brochure, allowing for a 3% wheel slip. So that'll be that 1.61 multiplied by 0.97 to minus that 3% slip. And so your answer that you will get for this calculation is 18.32 hours. So now you want to know what the gross application is. So you want to know how much water did the center pivot apply during this time, and that'll be calculated with the formula of Q times T divided by 10 times the area. So that Q is the flow rate, so the rate at which water is moving out of the center pivot, and that is 103 cubic meters per hour, multiply by that time that was calculated in the previous sum. So divided by 10 and then divided by the area. So and then this area should be in hectares. So you know that this point from the center of the circle to the edges of the circle is 310.5 meters. So the area of a circle is pi radius squared. So you'll take that and say that 310,5 squared times pi, and then divided by 10,000 to get your hectares, and that'll give you an answer of 6,56 millimeters. Okay, so now this was calculated for if the center pivot is moving at 100% speed of the speed that it can run at. So now it's saying that it is running at 50% of that speed. So in order to calculate the rotation time at 50% speed, it's going to be that 18,32 hours divided by 0,5. And for that gross application, it's going to be that 6,56 divided by that 0,5, and that'll give you the gross application and rotation time at those speeds.